I welcome you all to the Spark Research YouTube channel. This is Dr. Vichandra, Assistant Professor in the Department of ECE. And if you are preparing for GATE 2027, then this series, will be very helpful for you. And because in this series, we are not only talking about the questions which has already been asked in GATE 2026, the last year, in a very detailed analysis, but also we are trying to get the concept from the very scratch, the basics, right? So currently this is the third session, so you can the in these sessions we are talking about the particular course analog and digital communication, and we'll continue to talk about the remaining also topics, right? So this question belongs to the the PCA passcode modulation and a little bit about the information theory aspects. So here is the syllabus for your communication course, and this question is the related to this digital communication. You can say the combination of information and the PCM, right? So let's check the question here. So what is the question? Question is that a wireless digital transmission scheme is 16 QAM, right? With over an additive white Gaussian noise. So two informations are given. First is that digital transmission system, of course, no problem. Second, the information is that the type of the modulation that we are using, this 16 QAM. That is, what is the meaning of this QM? Quadrature amplitude modulation, right? And over an additive white Gaussian noise. So a standard Gaussian noise, like whenever you are sending through the wireless, then definitely you have to consider the standard Gaussian noise, right? Noise will be there, of course. Channel and maximum likelihood receivers. So receiver that we are going to use, that will we have the maximum likelihood option. Now consider the information bit rate from a source to be 4 into 10 to the power 6 bits per second. So 4 Mbps information rate is there. So now question is being asked, the minimum transmission bandwidth of modulated signal necessary for optimum recovery of the information at the receiver is, right? So what should be the minimum bandwidth for this transmission, so that we can not only receive the message but also we can recover the original message. This is the target, right? So how can we find out? So here suppose let us try to understand more the question in more details. So you have the information sources and what type of modulation technique we are using, that is 16 QAM. And then you, after modulating, you can send to the wireless, the air means cloud. And here again the message, the some noise will be added. So the type of noise is being added is your additive white Gaussian noise. And at the receiver, this is your the receiver end. And so here the maximum likelihood receiver you are using, and then you are going to extract the information. So here modulation scheme, what type of modulation scheme are we using? 16 QAM constellation, right? So here you can see it means the how many different symbols are we using. So total 16 different symbols we can use. And like what are the 16, so you can check it, these are the types. And so what are the chances that whatever like what should be the bandwidth, so that you can recover the masses and from the modulated signal, right? So this is the question being asked here. So let's see the solution. As per answer key, your answer should be like 1, right? So let's see. So in the question itself, it is given what is the data source, like what is the information rate. So that is given 4 Mbps, that is 4 into 10 to the power 6 bits per second. This is the information rate already given, which is a stream. And we are going to use the 16 QAM technique. So this is also have the given. And then Gaussian noise, that is additive white Gaussian noise, and then receive maximum high likelihood receiver. We are going to use it here. So first of all, we have to find out the how many bits per symbol are being used here. So how we'll find out? So n is equal to log of 2m. So from here we can find the how many bits, right? So total how many different symbols are here being used? So 16. So put the value of the 16, and then you can find out the how many bits required here. So total how many bits required here? So total 4 bits we need, right? and then what will be the symbol rate finally. So symbol rate, that is R of S, will be can be calculated is equal to your bit rate, that is how many bits rate, and divided by the how many bits do we need, right? Total since 4 bits we need, so your information, that is how many information, so that you can put like RB, and how many bits like we are going to use it here, so you can put N, and then you can calculate the how many symbols the we need. So total how many symbols if you put, then you will get the 1 megahertz symbols per second we are transmitting, in order to write we are transmitting. And in order to determine the minimum bandwidth for Nyquist criteria, since this is the QAM type of the modulation, so here both are equal, right? Means the minimum bandwidth and your symbol rate, like how many total symbols per second you are transmitting, both will be same. So finally your answer is 1 megahertz. So this much symbol rate, that is the bandwidth, is required in order to recover the masses. So first calculate the how many bits we are going to use, and then data rates already is given in the question, and divide it in order to get the how many symbols we are going to transmit per second, and that symbol rate will be equal to the bandwidth of the Nyquist as per the Nyquist criteria. Okay. So here is some more calculations. First find out how many bits we need. So you can calculate 4 symbols, and then find out the the data rates. And data rates already given, so that is the 10 to the 4 into 10 to the power 6. And symbol rate, that is we have to find out the symbol rate. So symbol rate in data rate, that is information rate divided by the the number of bits that we are using, and that will be the a symbol rate, that is that will be equal to the beta minimum, that is the bandwidth minimum. So bandwidth minimum will be the how much coherent and non-coherent, right? Now here is the some details about the QAM. QAM is nothing, quadrangular amplitude modulation, the combination of the two things. What are that? Amplitude modulation and phase modulation, using two coils that have the 90-degree out of the phase here, right? How will you generate? So here is your generation techniques, your the phase difference that you are going to give, then frequency is already you are going to use, that is omega ct carrier frequency, so that will give you the QAM type of the results. So in the detector side, again local oscillator will be used, phase shifter will also be used, and then low pass filter for coherent detection, right? Signal space diagram you can see here for QAM side, like here phase is there and amplitude is on the y-axis. So here the point is representing the number of the signals that we are using. So here like this is not the binary, here 4 4 4 total 16 signals are there. So that we can increase the number of signals using the QAM technique, like the combination of the amplitude and phase modulation. So that is why this is the better one, because you can increase the bandwidth. We can increase the transmission rate further by using, so that is the target. So you can check that this the QAM is one of the important. So that's all in the session. Thank you to join. So play today, stay healthy tomorrow, and learn for a lifetime.